Welcome to Google Cloud Next. In this session, we will talk about how to maximize the availability of your Cloud SQL databases. My name is Rahul Deshmukh. I'm a product manager for Cloud SQL at Google Cloud. In this session, we will talk about what Cloud SQL is, how you can maximize the availability of your application using the many different features and controls that Cloud SQL provides. And then finally, we will discuss how Cloud SQL is helping you rewrite your DR playbook so that it becomes a haiku. Let's get started. So what is Cloud SQL? Cloud SQL is Google Cloud's fully managed relational database service. It is trusted by more than 95% of Google Cloud's top 100 customers. Cloud SQL offers full compatibility with source database engines, whether it is MySQL, PostgreSQL, or Microsoft SQL Server. Cloud SQL is very easy to set up and manage. It makes typical administrative operations like backups, point-in-time recovery, authentication, administration, simple and easy for any enterprise to use. Cloud SQL is trusted and reliable. We offer a 99.99% uptime SLA inclusive of the maintenance downtime. And we love our developers. Cloud SQL is developer friendly. We are an API-first service. Any feature you can think of, you can use it with the REST API. To ensure that our users can run their most critical workloads while also optimizing for cost and get a better performance out of it, Cloud SQL introduced Enterprise Plus. Enterprise Plus offers three key features. One is better price performance. You can get a 3 times better read performance compared to the Cloud SQL Enterprise Edition using the data cache and using the other features that Cloud SQL offers. To ensure that our users get the best out of Cloud SQL for their most critical workloads, we introduced Enterprise Plus Edition in 2023. With Enterprise Plus Edition, you can get a 3 times performance boost using the optional data cache as compared to the Cloud SQL Enterprise Edition. With Cloud SQL Enterprise Plus, you get a near zero downtime planned maintenance and a 99.99% uptime SLA, also known as a 4 nines SLA. And you get extended point-in-time recovery retention with up to 35 days with the logs getting stored in a Google Cloud Storage bucket. And our customers have been loving this edition, and they have been migrating their instances to leverage the better price performance, availability, and the improved data protection, as you can see from the slide. Talking of availability, let's talk about how Cloud SQL can help you maximize the availability of your critical applications. When we think about availability, it's all about preparing for any disruptions that may occur on your instance. These disruptions can typically be categorized as planned and unplanned. When we're thinking about planned disruptions, the first thing that comes to your mind is maintenance. Now, maintenance is critical for your instance. It gives your database the necessary security fixes, any new features that have been made available, and it also introduces new Cloud SQL features through the maintenance event. But at the same time, maintenance also introduces downtime, and that's why preparing for maintenance and ensuring that you have the right controls is important. The other planned disruption is scaling of an instance. As applications evolve, so does the need to scale your instance. And as you're scaling your instance, whether you're scaling it up or down, whether you're changing the storage or your memory or the number of vCPUs, you need to be prepared for the disruption that it is going to cause for your instance. And then finally, there may be other configuration changes, newer security controls that you may want to use, which can also result in a disruption. Now let's talk about unplanned disruptions. Within unplanned disruptions, typically they fall into failure within a zone, failure that spans across multiple zones, and then finally an error caused by a user, which can also result in an unplanned downtime. In the next few minutes, we will go through how Cloud SQL helps you prepare and maximize the availability through both these planned and unplanned disruptions. Let's start with maintenance. With Enterprise Plus, Cloud SQL introduced near zero downtime maintenance. With near zero downtime maintenance, as your Cloud SQL instance undergoes the quarterly maintenance event, it results in a downtime of less than 10 seconds. And this maintenance event results in no data loss, and it has no proxy dependency whatsoever. As long as you meet the instance configuration criteria, your instance will get a near zero downtime. It does not require any app configuration changes either. The maintenance happens and the instance comes back up with the same IP address so that the app does not need to be changed at all. And then finally, near zero downtime maintenance supports all combinations of IP addresses, whether it's private IP, public IP, or both. So how does this near zero downtime work? Let's take a quick look. The first thing that happens is when the maintenance event begins, Cloud SQL creates a shadow replica, which is also a highly available replica with its primary coinciding and co-locating with the same zone where the current primary instance is running, and its standby co-located with the standby of the current primary instance. So as you can see, my primary and shadow replica are in zone A, and both my standby are in zone B. Now, once this shadow replica fully catches up to the primary instance, Cloud SQL takes a brief interruption and quickly cuts over by promoting the shadow replica and making it a primary instance. And as soon as that happens, Cloud SQL starts redirecting the incoming connections to the new primary instance, thus ending the disruption and allowing your applications to reconnect and start using Cloud SQL instance right away. So this is how Cloud SQL performs near zero downtime maintenance. And I'm happy to announce that since the launch of Enterprise Plus and near zero downtime maintenance in July 2023, the Cloud SQL team has been hard at work at reducing this downtime further. And as a result, now the downtime is less than 1 second. We are calling it sub-second downtime maintenance. Let's take a quick look. So in this simple and quick demo, I have a Enterprise Plus PostgreSQL instance with a data cache enabled, high availability, point-in-time recovery. I have a simple application. It's going to connect to my PostgreSQL instance. It's going to query the current timestamp, and it's going to print it on the screen so that we know when the downtime has begun and when it has ended. I'm going to run this simple script. Now I'm going to switch back to my instance. I'm going to perform a self-service maintenance event on the instance by entering the instance name and clicking on Apply Update. Now, once the maintenance event begins, as you know, Cloud SQL is creating a shadow replica. The replica is catching up. And then once it has caught up, you will see that the actual downtime will happen. And the downtime, as you can see now, is 780 milliseconds, which is less than 1 second. That's the sub-second downtime for you. And the instance now says that it is fully caught up with no pending maintenance. Now, you may be wondering how you can leverage and ensure that you get this sub-second downtime for your particular critical database, no matter how busy it is. For this, we have also introduced a new feature called near zero downtime maintenance simulation. With near zero downtime maintenance simulation, you can simulate this whole near zero downtime maintenance workflow without having to worry about your database engine receiving a newer update. All you have to do is say simulate maintenance event, and Cloud SQL will send your instance through the whole near zero downtime process so that you can check the downtime from the application side and find the right day of the week and time when you should accept the maintenance where the downtime is less than 1 second. And that's the maintenance window that you should set for your instance. So we talked about planned maintenance. Now let's talk about scaling your instance. As applications evolve, your instance will need to evolve with them. And it typically requires that you will need to scale up your instance. Scaling up your instance could mean scaling up the compute and/or scaling up the storage. Cloud SQL already offers a zero downtime auto scale up for your underlying storage. You can scale up your storage all the way to 64 terabytes in size and 100,000 read IOPS and 80,000 write IOPS. But what about the compute? Well, I'm very happy to let you know that with Enterprise Plus Edition, now you can scale up your Cloud SQL instance with near zero downtime as well. You can take your Enterprise Plus instance and go all the way up to 120 vCPU, 864 GB of memory, and 9000 GB of data cache with less than 10 seconds of downtime. Let's take a quick look. Now, this is going to look very, very familiar. I have my same Postgres instance, but this time I'm going to look at its configuration. It is a 4 vCPU, 32 GB Enterprise Plus Edition instance. I'm going to run my trusty app again. It's going to keep throwing the current timestamp on the screen. And once it does that, I'm going to go back and I'm going to update my instance by doubling its size. So I'm going to say edit the instance configuration and change its machine configuration from 4 to 8 vCPU and 64 GB memory. Save and restart. And then as the restart is happening, the same near zero downtime workflow will take place. And you can see that the downtime in this case is less than 1 second, and the instance has scaled up. It is now showing that it is a 64 GB and 8 vCPU instance. So we talked about two of the most common planned operations that your instance goes through: planned maintenance and instance scaling. For planned maintenance though, just knowing that your downtime is going to be less than a second is typically not enough. It's also important to make sure that you're testing the maintenance for your particular application and ensuring that your application will continue to work successfully and use the new maintenance version. To do that, Cloud SQL already offers you the ability to accept maintenance 1 or 2 weeks from the time the notification goes out. But now, I'm very happy to announce that we have introduced 5 weeks of advanced maintenance notification. You can set this maintenance timing as week 5 for your critical applications, for your critical databases. You can accept the maintenance on your test instances in week 1, which gives you 4 weeks of duration to accept the maintenance, test it on your lower environment, and ensure that you're ready for it when it gets to your critical production instance in week 5. You can also use this duration to notify your stakeholders of this upcoming change so that they are ready as well. And then when the maintenance happens, the downtime will be less than 1 second. And so this is how we are ensuring that your planned operations can continue to run successfully and will result in little to no disruption for your production instances. But so far, we have been discussing planned operations. Yes, they do cause a minor disruption, but that's known and that's within your control. But what about things that are beyond your control, such as a disaster? If an event that occurs which can cause a zonal or multi-zonal or a regional disruption, how are you preparing for it? Typically, enterprises such as yourselves ensure that they have a tested disaster recovery playbook where you are performing the disaster recovery operations on an ongoing basis to ensure that if a disaster strikes, you are ready for it. But this disaster recovery typically involves multiple steps which are very complicated. And so we at Cloud SQL have been hard at work trying to rewrite this DR playbook and make it very, very simple for you. Cloud SQL already offers you cross-region read replicas for performing disaster recovery with very little recovery time objective, also known as RTO. With cross-region read replicas, you can recover from regional failures within minutes. You just need to create a cross-region read replica, and in case of a disaster on the primary region, promote that replica, and you're good to go. Cloud SQL also allows you to configure your cross-region replicas to be of a different size, which you can use to ensure that you're optimizing the cost of your DR replica by configuring it at a smaller size than your current primary instance. You can also configure high availability on your cross-region replica. This helps when you need to promote that replica and make it a primary instance. If it already has high availability enabled, you can finish the promotion quickly and you don't need to take another downtime just to enable HA on that instance. Cloud SQL also supports the creation of cascading read replicas whose source is another read replica. And in this case, the promotion of a replica to be a primary instance means that its cascading replica is already there and is already able to use the primary instance. And so as you can see on this slide, If instance 1 is down, you will go and promote instance 3. It already has high availability enabled. It has a cascading replica, and you're able to quickly perform the promotion and perform the disaster recovery with little recovery time objective. But what about reverting back from the DR region to the primary region? What about performing this operation on an ongoing basis as a DR drill? This is where advanced disaster recovery comes into picture. With advanced disaster recovery, we have simplified DR and the simulation of disaster. Advanced disaster recovery offers two key features. With replica failover, when you promote a cross-region replica, Cloud SQL will go check, and when the old primary instance comes up, it will recreate it as a replica of the new primary instance. And then when you're ready to go back to your old primary instance, you will be able to perform a switchover operation which performs the switch between a DR replica and a primary replica with zero data loss. And you can also use the switchover functionality not only to revert back to your original primary region, but to also perform a routine DR drill without worrying about data loss that it can cause. So let's see how this actually looks in, how this actually works. So the first thing that I'm going to do for my configuration is that I'm going to take my cross-region read replica, which is instance 3, and I'm going to designate it as a DR replica by saying my failover DR replica name is instance 3. Once I do that, if there is a disruption on the primary region and the primary region is not available, I can go ahead and promote instance 3 with an additional option called failover. Once I do this replica failover, instance 3 will get promoted. It will become a primary instance, which is very similar to how replica promotion happens today without advanced disaster recovery. But the new thing that will happen is once the old primary comes up, Cloud SQL will recreate it as a replica of the new primary instance. And in this case, since Cloud SQL knows that instance 1 used to be a primary instance, it will automatically configure it as a DR replica of instance 3. And instance 2 is also recreated, and it has now become a cascading replica of instance 1. And when you're ready to go back to region A, because that's where your application, your users are, and so you need to revert back to region A, but you don't want to accept another data loss, and you want to make sure that this is all fully managed for you, all you have to do is perform a switchover operation. When you say, I want to switch over to my current DR replica, which is instance 1, Cloud SQL will stop accepting writes on the current primary instance, instance 3, which will allow the replication lag to instance 1 to get down to 0. And then as soon as that happens, instance 1 is promoted, instance 3 is reconfigured, and you have fully recovered from the disaster by going back to your original topology, with instance 1 being the primary, 3 being the DR replica, and your applications connecting to instance 1 in this case. So this is how Cloud SQL makes it very easy for you to set up and perform disaster recovery with advanced DR. Let's take a quick look at a demo. In this demo, I have a Enterprise plus MySQL instance, and I have 3 replicas of this instance. I have a same region replica and a couple of cross-region replicas. Now, what I'm going to do is, first I'm going to designate my DR replica, which is my MySQL region 2 replica name. So let me do that. So I'm going to say patch my instance, designate a DR replica. It's a metadata operation, does not require a restart, it's done. Then let's pretend that there is a failure on the primary region. I'm going to say I want to perform a promote failover to my cross-region replica. And once that operation has fully finished, the old primary is also reconfigured. And so when I go to my replication tab, I can see that my DR replica is now the primary, and my old primary has now become a replica. So as you can see, MySQL region 2 is the new primary, and prod backend MySQL is my DR replica. Now let's say that I'm ready to switch back to my original primary region. All I have to do is say switch over back to prod backend MySQL. Do you want to continue? Yes. And once the switchover has finished, if I go back to my replication tab on the console, I will see that prod backend MySQL is back to being my primary instance, and MySQL region 2 is back to being my DR replica, fully restoring my original topology. So in this session, we looked at how Cloud SQL helps you maximize the availability of your database instance by offering you sub-second downtime for day 2 operations like planned maintenance, instance scale-up, 5 weeks of advanced notification for upcoming planned maintenance so that you are ready, prepared, and you have tested the maintenance and you are ready to accept it. And a robust DR strategy so that if there is a regional outage, you're fully prepared and you can quickly recover from the outage and then revert back to your original region with little to no operational toil. So I hope you enjoyed this session. Thank you for joining me. I'll see you soon.